All right, welcome to Geometry for AP. Today we're talking about rotating a figure about a point that is not the origin. This can be difficult. It will be one of the more difficult things to explain in geometry and a little bit difficult to do. If you catch on to graphing slope and know how perpendicular lines are graphed, that will make your life so much easier for this process. All right, so rotating a figure about a point that is not the origin. Let's check first thing. For slopes of 2/3, what would the perpendicular for a slope of 2/3 be? And write it in two different ways. So if you want to pause the video and answer that, that'd be great. All right, so if we look at it, remember that the perpendicular is the opposite reciprocal. So the opposite reciprocal of 2/3 would be -3/2, or it would be 3/2. Both those are the perpendicular. One has the negative in the top, the other one has the negative in the bottom. Being able to know which one gets which way will make a difference, okay? So if I look at something, one of these will be a 90 degrees counterclockwise rotation, and the other one will be a 270 degrees counterclockwise rotation. And we'll explain that as we go through the practice problems a little bit. So, we're going to do this the hard way the first time. All right, so the first one. We want to rotate this figure 90 degrees counterclockwise rotation about the point -3, 3. So the first thing we want to do is we want to think about, well, how do I move this point right here, my point of rotation, to the center, back to the origin? And I would rotate that point. So the motion rule is I would move that point to the center by saying 3 added to the x value and 3 added to the y value. Okay. And when I have that, okay, I'm just going to give myself room. We're going to need a lot of room here. Let's give these points some letters. So A, B, C. So point A started out as -8, -5. B started out as -5, -8. And C started out as -4, -6. All right, and so we'd add 3 and add 3 to move that point to origin, the rotation point to the origin. So I got to move the rest of the figure that same distance. So I add 3 to each of these. So I'm going to pause this video, write them all down, and then you'll see them all. Okay, so I moved all of these points, A, B, and C, to A prime, B prime, and C prime. So this green triangle represents the triangle's been shifted because I moved that purple point to the origin. So I've kind of shifted everything. Now I got to do the motion rule for a 90 degrees rotation. So the motion rule for 90 degrees rotation, right, is -y, x. All right, so we're going to change that. A double prime is going to be 2, -5. B double prime is going to be 5, -2. And C double prime is going to be 3, -1. And so we're going to graph this. And so that's 2, -5. That's here. That's 5, -2. That's right there. So that's B double prime. This was A double prime. And then 3, -1, which is here. And that's C double prime. And so when I connect these, all right, and let's go in here. This was my A prime, my B prime, and my C prime. So I did this figure and I rotated it 90 degrees counterclockwise. But remember that I moved that purple point to the blue position. So now I got to shift everything again and move everything back. So if I did +3 and +3 on the Y and +3 on X, now I got to do the opposite, would be X -3, Y -3 to move it all back again. All right, I'm going to pause the video and write all those points down. So here are my red points that I moved them back. And now this is a 90-degree rotation. So C went from here, B went to over here, and A went to here about that purple point right there, which was -3, 3. So we did a 90-degree rotation. So we had to move it to the origin, do the rule, then move it back to where it originally was, and that gets us the final answer. So the red is the final answer that we have. So it took me 1, 2, 3 different transformations to get to that one answer. Now, how would you like it if I told you I could do this in just a few seconds? or maybe a few minutes just by knowing a few little pieces of information. I'm sure that'll probably make you a lot happier. So if we look here, here are the rules. And so here I ran through that process again. So first thing we list our points. Whoops. And so here are, sorry, I got my highlighter on. So we listed those points. All right, so here are my points. Move the point to the origin. So we moved all of our points, which was here. Then we did our motion rule. There was our motion rule. And then finally we shifted all the points back, and so we moved them back. And that's how we got our final answer. Okay? All right, now. Let me show you how I can get from this answer to this answer very quickly. All right, so let me give these points. So I said A, B, and C. All right, so how do I go from A to my point of rotation? We're going to call that point R. Okay, what's the slope from A to R? That's 1, 2 up, and 1, 2, 3, 4, 5 to the right. So that's 2 up and 5 to the right. Would everybody agree? I hope so. All right, and so that's the slope of this line. So what would be the perpendicular from A to R? That'd be -5/2, wouldn't it? Now, I can go down 5 from this point, purple point. So 1, 2, 3, 4, 5, and to the right, which would be here. Or I can do the reverse of that, which is 1, 2, 3, 4, 5 up, and 2 over. So I have two different points. All right, I'm going to make these points green. All right, I have two different points. All right, so if I look from A to R, and I connect these, this one is going 90 degrees counterclockwise, right? And this one's going 90 degrees clockwise. But 90 degrees clockwise is the same thing as 270 degrees counterclockwise. So if I have a 270 degrees counterclockwise, I go up, and if I went 90 degrees counterclockwise, I went down with that point. And so that's where I get to this point. So now let's look at B to R. What's the slope from B to R? So from B to R would be 1, 2, 3, 4, 5 up, and 2 to the right. So 5 up and 2 to the right. So the perpendicular of BR would be -2/5. So I can go down 2 and 1, 2, 3, 4, 5 to the right, or 1, 2, and 1, 2, 3, 4, 5 to the left. One of these is at 90 degrees counterclockwise, the other one's 270 counterclockwise. So I have to know which rule I'm going to do. And finally, let's run to the last point. C to R. The slope from C to R will be 1, 2, 3 up, and 1 to the right. And so the perpendicular for CR will be -1/3. So 1 down and 3 over, or 1 up, 1, 2, 3 this way. So this figure over here, this green one's not right, but this one over here, the red one, it is the right figure because this is the one that is 90 degrees counterclockwise. The green one, this is a 270 counterclockwise rotation. This is the 90 degrees rotation. So what did I use to do this? I just used slope. The slope of a perpendicular line forms a 90-degree angle. So it gives us the distance. That slope being done that one time and not changing or reducing that slope gives us the distance away from that point of rotation, and so it all works out. I use slope all the time. Now, slope is a lot easier than trying to do 4 different transformations or 3 different transformations. So you've got to pick your method. All right. Now, the blue one is the 180-degree rotation. So see if you can practice that one and get that one. Now, if I'm going to do a 180-degree rotation, all I do is I connect. I'll use my line tool here. How about that? All right. Well, let's see here. I want it to be a nice thin line. So if I connect this point to the rotation, all right, for each one of these, all right. So if I look here, I go from this point right here. Let's give these points some letters that'll help us to talk about them. So A, B, C. All right. If I go from A to R, my rotation point, so I go 1, 2 up, and 1, 2, 3, 4, 5 over. I go 2 up, 1, 2 up, and 1, 2, 3, 4, 5 over. And that gets me my new point, A prime. That's 180 degrees. Remember, a straight angle is 180 degrees, so that's 180-degree rotation. So I go from B to R. So 1, 2, 3, 4, 5 up, and 1, 2 over. 1, 2, 3, 4, 5 up, and 1, 2 over. What do you know? There's B prime. And finally, C is 1, 2, 3 up, and 1 over. So 1, 2, 3 up, 1 over. Remember that these are all on the line, and lines are 180 degrees. Remember, we know that from the very first week of 6 weeks. And so there's my A, B, C prime. Much easier than memorizing a rule is just to know that it's 180 degrees. If not, you'd have to do all those 3 transformations to get this to happen. All right. The last one we have is a 270-degree rotation. Now remember, we did it already. It's the green one. So instead of going down, which is 90 degrees counterclockwise, I went up to this one and it got me that 270 degrees. So you have to think about how that rotation works. And that gives you the idea of 90. So one direction is always 90 and the other side is always 270. So you have to think your way around that a little bit. So you got to use your brain power a little bit. All right. And so finally, there's the green one right here. This is the 270-degree rotation. This one was the 180-degree rotation. This was the 90-degree rotation. These were all about a point that's not the origin. The rules only work if you move it back to the origin, which doubles the number of steps you have to do in order to get it. Okay? So here's your practice problem. Pause the video, practice it. We'll check it when you come to class the next day if you want to check it. So this is one for you to do. All right, when you're done with that one, we're going to go to another one so you can start the video back again. All right, and there's your answer to check with. Okay, here's another one for you to do. You remember to pause the video and do this one. And there's your answer there to check with. And here's your last one. So pause the video and do this one. And so I'm not going to show you the answer to this one so that you can show me this one when you come to class also. Make sure you try these, guys. I'm going to put these on the test. And so therefore, you need to be able to do that rotation. It's about a point that's not the origin.